Welcome to Easy Alim Learning Simplified. My name is Ruth, and today we are going to be discussing on the action of heat on salts. So previously we looked at different methods of preparing different salts, both soluble and insoluble. So we are going to do this in two parts because we are going to look at different types of salts and how they behave when you heat them. This is a subtopic that is repeated again in Form 3 as we talk about and also in carbon and its compounds as we heat those salts once more. So for today, we'll look at carbonates and nitrates. Carbonates are repeated again in carbon and its compounds. Nitrates are repeated in nitrogen and its compounds, so you can check out those videos as well. So when it comes to heating carbonates, for sodium carbonate and potassium carbonate, they do not decompose on heating. If they are hydrated, they usually only just lose their water of crystallization. But other metal carbonates usually decompose on heating to form their oxides and carbon 4 oxide. So carbon 4 oxide that is produced in the reaction usually forms a white precipitate with lime water because it produces calcium carbonate. So the white precipitate dissolves in the gas if you continue bubbling it. This is because of formation of the hydrogen carbonate. So for example, if we take our copper carbonate, this is not a sodium carbonate and it's not potassium. So it's definitely going to decompose. So if we decompose, usually show a heat or you write heat when you're writing your equation. Ensure that it's there. Because if you lack that there, you're going to miss out some marks when the marking is going to happen. So copper carbonate, we said, decomposes to form the oxide. So you're going to form copper oxide, which is in solid state. Remember, copper oxide is black in color. And then we're also going to form carbon 4 oxide, which is gaseous in state. So if you look at this equation, it is completely balanced. You can see we have one copper, and three oxygens, and one carbon. So this is how we decompose copper carbonate. Next, we look at calcium carbonate. Remember, we write the arrow, we show the heating sign, or you write heat. So calcium carbonate also decomposes to form calcium oxide with carbon 4 oxide, and also this equation is balanced. We have lead carbonate. If you decompose lead carbonate, you form lead oxide plus also carbon 4 oxide gas. Remember, lead oxide is yellow when cold, red or orange when hot, and yes, yellow when cold and orange when hot. Then we have iron carbonate. When you heat it, don't forget the heat sign, you form iron oxide or 2 oxide plus carbon 4 oxide. Remember, iron 2 oxide is brown in color. And then finally, zinc carbonate. When you heat zinc carbonate, you form zinc oxide plus carbon 4 oxide. So the zinc oxide is white when cold and yellow when hot. Do not forget these colors. You can check them out again. We discussed them, the oxides in Form 1. So another exception comes in with ammonium carbonate. When you dissolve ammonium carbonate, you form ammonia, carbon 4 oxide, and steam. And the presence of ammonia is confirmed by turning, because it turns red litmus paper blue. It's one of the gases that is basic in nature. So the ammonia reacts the ammonium carbonate. So it decomposes, we said, to form ammonia gas and carbon 4 oxide gas and steam. So we balance the equation by putting a 2 in front of ammonia. And then when you come to the hydrogen carbonates, the sodium hydrogen carbonate and potassium hydrogen carbonate are usually decomposed to give their corresponding carbonates in water and carbon 4 oxide. So for example, if we heat sodium hydrogen carbonate, we are going to form sodium carbonate plus carbon 4 oxide and water. So when we balance this equation, of course, there will be a 2 in front of sodium, so that can, because there are 2 sodiums, and then 2 hydrogens, 2 carbons, and 6 oxygens. Next is potassium hydrogen carbonate. So it also forms potassium carbonate plus carbon 4 oxide plus water. Remember, we said this sodium carbonate and potassium carbonate, you cannot decompose them. But for the sodium hydrogen carbonate and potassium hydrogen carbonate, they decompose partially or not fully to form their carbonates, carbon 4 oxide, and water. And then for the others now, that is calcium hydrogen carbonate and magnesium hydrogen carbonate, they produce their carbonates as well, water and carbon 4 oxide. So we form calcium carbonate, water, and carbon 4 oxide. So you can see it is balanced. And then also magnesium hydrogen carbonate will form magnesium carbonate. Remember, this is solid, water, and carbon 4 oxide gas. It is also balanced. And then next we look at the effect of heat on nitrates. Nitrates are usually when you heat them, they usually the product depends on where they are on the periodic table. So as you go down the periodic table, you notice the decomposition becomes more and more. So it decomposes less in the elements in the reactivity series, they are nitrates. But as you go lower and lower in the reactivity series, you're able to even obtain their metals. So when you look at potassium nitrate and sodium nitrates, when they decompose on heating, they usually produce potassium nitrite. They do not decompose fully in oxygen gas. So for example, potassium nitrate in this case is going to form potassium nitrite with a 2 plus oxygen gas. So it is balanced. So you just put a 2 here to balance it out. And then sodium nitrate is still the same. Remember, there's a heat sign. Let's not forget the heat sign to form sodium nitrite plus oxygen gas. So we put a 2 here. And then as we now go down in the reactivity series, for the other metals, they usually decompose to form their oxides and nitrogen 4 oxide and oxygen. So for example, if it's calcium nitrate, when you heat it, you're going to form calcium oxide plus nitrogen 4 oxide plus oxygen gas. It's like that. So you can see we have to balance this equation. So this equation is balanced. So we have one calcium, and then we have 2 nitrogens, and then we have 6 oxygen. So we said calcium is 1, both sides, nitrogen is 1, both sides, oxygens are 6, but this side the oxygens are they are 5. So if we put a 2 in front here, it's not going to solve it because we'll be having 4 oxygen plus 3, which will give us 7. So we are going to put 2 in front of calcium nitrate and 2 in front of calcium oxide. So we'll get 2 calciums to 4 nitrogens and 12 oxygens. So far we have 2 oxygens in calcium oxide, 2 oxygen in nitrogen 4 oxide, and 2 oxygen in oxygen. So if we put a 4, because we have noticed that we have 4 nitrogens. Let's see if it's going to balance. So we have 2 calciums, and then 4 nitrogens, and then oxygens are 12. So it is 2 plus 8 plus 2, which gives us 12. So this equation is balanced. So magnesium nitrate, we do the same. You're going to notice they have the same valency. So it becomes 2 magnesium oxide plus nitrogen 4 oxide gas plus oxygen gas. Zinc nitrate as well. So it's going to be zinc oxide to form nitrogen 4 oxide gas plus oxygen gas, and then we put a 2 here and a 2 here and a 4. And then we have also lead nitrate. Remember the oxide is yellow when cold and orange when hot. And the nitrogen 4 oxide gas we are producing is brown in color. We are going to look at this in details later when we get to form 3. And then copper nitrate also decomposes to form copper oxide plus nitrogen 4 oxide plus oxygen gas. As we continue now down the group, you notice we also have silver nitrate, mercury. So for these ones, they usually decompose to form now metals, nitrogen 4 oxide and oxygen. So for example, silver nitrate is going to be heated to produce silver metal plus nitrogen 4 oxide plus oxygen gas. So let's balance this equation. So we have one silver both sides, nitrogens are 1 both sides, the oxygens are not equal. So we need to equalize the oxygen. So you put a 2 in front of silver. It's going to give us 2 silver, so we have to put 2 here as well. So we have 2 nitrogen, so we have to put 2 here as well. So that gives us 6 oxygens in the reactant, 4 plus 2 in the product. So this is balanced. So the same case with mercury. When you heat it, you form mercury oxide plus nitrogen 4 oxide and oxygen gas. So let's balance. So mercury is 1 both sides, nitrogens are 2. So we need to put a 2 here. And then oxygens are 6. So when we put a 2 here, it becomes 4 oxygens plus 2 plus 1, which gives us 7 oxygens. So remember we placed mercury oxide, but it's not supposed to be mercury oxide, it's just mercury. So it's when we remove that oxide that was wrong, that was supposed to be just mercury. Remember we said when mercury nitrate is heated, it produces mercury, nitrogen oxide, and oxygen gas. So that balances the equation in this case. So I hope you have been able to see how these equations are usually balanced. So let's look at ammonium nitrate. So ammonium nitrate and nitrate usually decomposes to produce nitrogen 4 oxide and nitrogen gas, and also water is formed. So make sure you are able to see how these nitrates are decomposing. You see the sodium and potassium nitrate do not decompose completely. Other metals that are in between the reactivity series are decomposing partially as well. And then we go to metals like silver and mercury, they decompose fully to form the metals. So the question here is write an equation to show the effect on heat on nitrate of potassium. So we have potassium nitrate. If you heat it, we said you're going to form potassium nitrite. It does not decompose fully, plus oxygen gas. So we balance the equation. We said you put a 2 here and a 2 here. That's going to form a balanced equation. And then for silver nitrate, that is just what we have done. If you heat it, it decomposes fully to form silver metal plus nitrogen 4 oxide plus oxygen gas. So we said you're going to balance it out. You put a 2 here, a 2 here, and a 2 here, and it's balanced. So that explains on how we heat nitrates and carbon. The most common tested question is on nitrate. So you need to remember how these nitrates are heated, because they are also used in preparation of nitrogen 4 oxide, as you come to Form 3 to discuss that. So make sure you're able to see how that happens. So in the next lesson, you're going to see the remainder types of salts. We heat them, that's the sulfates, and then we are going to look at some uses of salt. So see you in the next lesson.